The best way to describe the chain rule, let's say you want to take a bus and go to Boston tonight. If you remember, they changed the fireworks till tonight in Boston. You say, I want to go watch the fireworks in Boston. And you go to Peter Pan and say, I want a bus to go from here to Boston. Sorry, we're not running to Boston. But you can get a bus to go from Springfield to Worcester, because there's no direct path to go from Springfield to Boston. And there's a bus that leaves Boston 25 minutes after you get there that goes to Boston. So instead of going from here to Boston directly, you go from here to Worcester, then from Worcester to Boston. That's really what the chain rule is. If you want to find dy dx, a lot of times y is not a function of x, or it's too difficult to do that. You can get to it by finding dy du times du dx. Notice mathematically, if you remember your algebra, what happens to du's if you want to cancel them out? Gone. And you end up with what? Dy dx.
What is du? It's just
Now, let's say I gave you this problem. Y equals, and I'll make it difficult for you because the bus is not running to Boston, x plus 5 to the power of 70. I made it 70, knowing probably none of you in the right mind will multiply this 70 times and try to get the answer. So it looks like we can't do it, but if we use the chain rule, we should be able to do it. How? How about let me create a new variable, call it u. Let u equals x plus 5. So now you can write y as what? U to the power of 70. Let's find the derivative of each one. Now the derivative of this will not be called dy dx because the function on the left is what? U. This will be called du dx. So what's the derivative of this one? 1. And the derivative of this will be called what? No, but what do we call it first? dy du. Sure. Because the variable on the left, the dependent variable is y, the independent is u. dy du, the derivative of that is going to be what? 70 u to the power of what? You say, oh, wait a minute. I wanted to find dy dx. I don't care about dy du. I want dy dx. I said, yep. But what is dy dx equal to? It's dy du times du dx. Do we have the answers to these pieces? What is dy dx? 70 u to what power? 69 times the derivative of du dx, which is what? 1. So what's the answer? 70 u to the 69. I guarantee you if you put this on the computer, they'll mark it wrong. Why? Because the computer doesn't even know what u is. The problem was given to you as x plus 5 to the 70. They wanted dy dx. Don't give me a u in it. So how do we change the u to x? Yep, you replace u again back with the value of u, which is x plus 5. So 70 times x plus 5 to the power of 69. So now we can find the derivative of any of them using this method. Well, it looks like you just move the power to the front and subtract 1 from the power, right? So let's see if it's always the case. Let's try a different example now. You might be right, I don't know. Let's try this one. Y equals x squared minus 7x to the power of 32. So we're going to let what? Let u equals what? X squared minus 7x. And I'm going to let y equals what? U to the power of 32. Oh, but that's 3 over 2, 32. I can tell you why, because I'm already thinking about the next example. Thinking of a square root for one, thinking for a fraction for the other one. So my mind is somewhere else, thinking 2 steps ahead. What's du dx? Two x minus 7. Okay. And what's dy du? It's 32 u to the power of what? 31. So you want to find dy dx? It's dy du times du dx. Do we know what dy du is? 32 u to the 31 times, do we know what du dx? 2x minus 7. Again, your answer has to be a function of x. They wanted dy dx, not dy du. So what's the last step? Yep. So that'll be 32. And what is u equal to? X squared minus 7x to what power? 31 times 2x minus 7. I can multiply the 32 by that, but I'm leaving like this for a reason. Let me go back to the previous one, just put the 1 here, leave it for a reason. And that's dy dx. I was thinking of square roots and fractions for the next example. And that's why I said in my mind when I wrote that number. Let's say I have y equals negative 9 over. Or let's make it, you know what, let's make it 1 for now. Let's make it 1 over. 1 over the square root of x squared minus 4. So you notice we use the chain rule when the power, you have a function on the right side and the power is not 1. Well, if you rewrite this problem, what will happen to it? It becomes x squared minus 4 to what power? Negative 1/2, right? When you bring it to the top, it's negative 1/2. So you want to think about the chain rule when that power, you have a function raised to a power that's not 1. That's not 1. Positive, negative, doesn't matter, but it's not 1. So now let's let u equals x squared minus 4. That means y becomes u to the power of what? Negative 1/2. What's the derivative of each one? The derivative of u, that's du dx, which is 2x. The derivative of this is going to be what? Negative 1/2 u to the 3/2. Negative 3/2. And if you want to clean it, that's negative 1 over 2, let's say u to the 3/2. It doesn't really matter which format you use. Maybe for now I will leave it like this. So what's dy dx? Dy du times du dx. I'm going to use that answer for dy dx, dy du. I didn't write dy du here. Okay. Let me write dy du so you know that's the derivative here. I forgot to write it there. So it's dy du, which is what? Negative 1/2 u to the power of negative 3/2 times the derivative of du dx, which is what? 2x. Negative 1/2. What is u? So that's the chain rule. But let's take a peek at that chain rule because nobody really likes it. Nobody likes the chain rule. It's not a bad way of doing it. It took about a page for it. Did you notice anything about all these derivatives? Let me go back to the first one. I probably can get the answer quicker than going through all of this. Let's take the first one. Let me write it down. I want to see if I can do them in one line. In one line. Each one of them. Here's the first one. Y equals x plus 5 to the power of 70. You want dy dx? Take the power, move it to the front. So we'll have what? 70 times what? X plus 5. And subtract 1 from the power, just like before. That'll make it what? 69. The only difference here, we're not done. The only difference, you have to multiply it by the derivative, what's inside the parentheses. And what is inside the parentheses, derivative of that? 1. Let's look at that answer. Is that the answer we got before? 70, x to the 69, x plus 5 times 1. Yep, the same as before, except the only addition times the derivative what's inside the parentheses here. Well, here's one for you. Y equals x squared minus 7x to the power of 32. What's the derivative of that? Move the power to the front, which is what? 32. X squared minus 7x to what power? 31. Here's the addition now. Times the derivative of what's inside the parentheses, which is what? 2x minus 7. Was that the answer for question number 2 and we did a whole page on it? The next one. The question we had that took a whole page for it too is this one. Y equals x squared minus 4 to the power of negative 1/2. The derivative of that. Negative 1/2 times x squared minus 4. Now subtract 1 from the power. What is minus 1/2 minus 1? Negative 3/2 times the derivative of what's inside the parentheses, which is what? 2x. Was that the answer for question number 3 we did? So instead of using the chain rule, a lot of people say, I'm not going to use that method. That's too many steps in it. I'm going to jump to it that way. That's why the two methods always in the same section. This is called the general power rule, or some people call it the extended power rule. Let's see what our book calls it. The general power rule. So the general power rule, here we go. It says if you have a function raised to a power, if you have a function raised to a power, the derivative of some function, f of x, raised to a power. I don't know how I'm going to write that. Like this. I have a function raised to a power. The answer to that, power, n, not 2, any power. I don't like all these bracket parentheses. Is you take that power to the front times the function raised to what power? N minus 1. And the last one in the box here times what? The derivative of the function. That's the general power rule. Let's practice few examples with it. F of x, I'll give you a minute to think about it, because it doesn't take that long. 3x minus 2x squared to the power 3. Let's find the derivative of that. Could it be 3 times what? 3x minus 2x squared to what power? 2, good. Times the derivative of what's inside the parentheses, and that's what? 3 minus 4x. One step. Here's another one. Y equals the cube root. Again, remember, we use this method when the exponent's different than 1. If the exponent is 1, there's no reason to use it. You can, but there's no reason to use it. If that power was 1, why would you go through that? And if you used it, there'll be 1 times to the power of 0. Anything to the 0 power is what? 1, so it's a waste of time. That's your answer. If you remember section 3132, that'll be a nightmare to do there. The 4-step process. Ooh. Don't want to think about it this way. What's the derivative of that? First, can you rewrite this? Because, again, the general power rule, when you have a function raised to a power, that doesn't look as if now a function raised to a power. Can we make it look like that? That's x squared minus 1 to what power? 2/3. I can use that general power rule. It says take the power, 2/3, x squared minus 1 to what power? Negative 1/3. Yep. 2/3 minus 1 is negative 1/3. Are we done? Times the derivative of what's inside of that, which is 2x. Now they might multiply the 2/3 and the 2x make it 4x over 3 if you want to. So you can write that 4x over 3 times x squared minus 1 to the negative 1/3. I don't know if they care this way or that way. They probably like it this way just to prove that you're doing the steps. I'm assuming that. Till you do the problems, then you'll let me know.
They seem to not care how much you simplify something.
No? Watch, having said that, George, next example, I'm going to say, What really matters when he says find the higher derivative. Because if you don't simplify, you're not going to be able to do the second derivative. So if they say find the second, third derivative, you want to simplify the previous ones. Let's try another one. We'll use g here. G sub t. I don't know, just change it. We always use x. Let's change it. Negative 7 over 2t minus 3 squared. I can rewrite that as what? Negative 7 times 2t minus 3 to what power? Negative 2. What's the derivative? Negative 7 times a negative 2. Remember, if you have numbers, you can multiply them out in the front. What's negative 2 times a negative 7? Positive 14, right? 2t minus 3 to what power? Minus 3, very good. Subtract 1 from the power. Times the derivative, what's inside of that, which is 2. You want to simplify that? 2 times the 14, which is what? 28 over 2t minus 3 to what power? Third. Notice you could have done this with the quotient method, but why should you? That's a lot quicker. Remember about the product rule? It says it comes in really handy when the powers start being different. So what about if I gave you this problem? If I said, y equals x squared plus 4 to the power of 6 times 2x minus 8 x squared to the power of negative 5. Now I'm getting crazy with it, having fun with it. I'm going to use the product rule. What's f of x here? F is the first one, right? We have a multiplication. This times that. X squared plus 4 to what power? 6. And what's the derivative of that? 6 times x squared plus 4 to the 5th times 2 what?
2x.
Yep, 2x. And g sub x is the second piece, and that's 2x minus 8x squared to the power of negative 5. And what's g sub prime? Hurry up if you want to go home early. Negative 5, right? 2x minus 8x squared to what power? Times the derivative, 2 minus 16x. You get all 4 pieces? We have a product. Y sub prime, it's f times g sub prime plus g times f prime. Just write small if you want to fit on one line. What's f? X squared plus 4 to the 6 times g sub prime, negative 5 times 2x minus 8x squared to the negative 6 times 2 minus 16x plus g sub x, which is 2x minus 8x squared to the negative 5 times the derivative f, which is 6 times x squared plus 4 to the power of 5 times the 2x. And if you are bored this weekend, go ahead and simplify that. Actually, it looks really hard to simplify, but it's not. Because if you look at it, just watch this. I wasn't about to simplify it. I was joking about it, but I opened my mouth. Now I gotta do something. If you look at this, the first piece, x squared plus 4 to the 6th power. And if you look at the second piece, that's what? 2x minus 8x squared to what power? Negative 6. And let me multiply the minus 5 times the 2, which is what? Negative 10 plus what? What's minus 5 times 16? Is that 80? That's the first piece. Plus the second piece, which is what? 2x minus 8x squared to what power? Negative 5 times x squared plus 4 to what power? 5 times, what is 6 times 2x? 12x.
Don't you still have to multiply the 2x minus 8x squared by the negative 5?
Nope. You have three things. You multiplying them. This times this or this times that. You don't multiply this times this and this times that. But if you look at both of these, they have something in common. You can factor out x squared plus 4 to the 5th power from both of them. See, this has 6 of them, and this has 5 of them. We take the smaller, right? Which is x squared plus 4 to the 5th power. Now let's look at these two. We take the smaller. Which one is the smaller of these two? That's the smaller of these two. Minus 6 is smaller than negative 5. So what's left in the first group? One of these and that one. And what's left in the second one? Oh, I shouldn't close that box because I'm not done with it. Plus, what's left in the other one? Remember, I took all of this. I took negative 6. I still have one of these. To the 1 power. Remember, minus 6 times 1 is what? The negative 5 times the 12x. Now close the box. So if you simplify what's inside this box, that's your answer. I should get my mouth shut up before. Yes?
Can you get around the quotient rule by using a general power rule?
Absolutely. Yep. That's a correct answer. The question, notice, a lot of people actually don't want to use the quotient rule. So when you have a fraction, and I'll give you one, don't worry about the simplifying, this is just me having fun here. When you have, let's say we have x plus, let's make it x squared plus 1 over x minus 6. And you want to take the derivative. Go, I really don't like the quotient rule. I'm not a big fan of it. You can rewrite that as x squared plus 1 times x minus 6 to the power of what? Negative 1. Now you can use the product rule because you have a multiplication. F of x is the first one. And what's the derivative of that? Is that 2x? And g sub x is what? x minus 6 to what power? Negative 1. The derivative of that, notice that power is different than 1. The extended power rule, the general power rule, is minus 1 to the power of negative 2 times the derivative of what's inside that, which happens to be 1. So what is your answer? F times g sub prime plus g times f prime. F is x squared plus 1. G sub prime is what? That's this one. Minus 1 times x minus 6 to the negative 2 plus g sub x times f prime, which is what? 2x. Again, if you look at these two, they have x minus 6 common to both of them. See that x minus 6? We take the smaller of the two. Anytime you factor, you're taking the smaller of the two. This is the smaller of the two. So if you wanted, you can rewrite that as x minus 6 to the negative 2. And what's left in the first group is what? This 1 times a minus 1. This times that. That's what's left. In the other group, now you have one of these left there. And if you do your math, I bet you it's the same answer. Because that x minus 6, negative 2, becomes x minus 6 squared in the bottom. Negative x squared. Negative 1 plus what? 2x squared minus 6 times 2, 12x. So what's my final answer? Is it x squared minus 12x minus 1 over x minus 6 squared? And if you stop here, they probably say that's fine. So a lot of people don't like the quotient rule. That's what they do. Yes?
So, that x squared minus 12x minus 1 over x minus 6 squared.
Yep.
Is that the answer?
That's correct. Yep.
Or
If
the other one, right?
this will be fine. That's also fine if they like that format.
Okay.
Any one of these is really good.
Okay.
If this one, you can't leave it like this. I mean, you got to simplify it.
Right.
So this is good. That's good. If they went this far, they probably want to simplify the inside, you know.
Okay.
But that will do it. This will do it. And George says they're not that picky, so they don't really care the software, any one of these answers. Now, what this method now does for us, let's go back to trig functions. Trig functions. We did the sine of x, the cosine of x, the derivative of them. So what happens if that's really not x there?